we often use a point in the plane to describe the position of an object. And you can use some coordinate system to describe the position of the object. So if you're using rectangular coordinates, it might look like this, x comma y in rectangular coordinates. But if the position of this object changes, so if this object is moving around, then this is the location of this object just at one particular time. So this might be at, say, t equals 0. And later on, at, say, t equals 1, maybe the object has moved over to this point. And at t equals 2, maybe it's moved over here. In this situation, this x coordinate and this y coordinate change as time changes because the point moves around, so its coordinates must change. So really, x comma y isn't the right way to think about the location of this point, because x isn't just a single number, it's actually a function of time. Since x changes as time changes, x really is a function of time. But then the same thing goes for y. Y is really a function of time, and you might write it like this, y of t, in rectangular coordinates. So this situation, we describe this sort of thing as, we call this a parametric curve. And parametric just means that where you are on the curve depends on some independent variable, and that variable is called the parameter, and in this case that's t. So t is sort of the traditional letter to use for a parameter if you don't have any better name for it. Okay, so in other contexts you might use some other variable like theta maybe in some contexts, but we'll use t. So a parametric curve is just an x-coordinate and a y-coordinate that both depend on some third parameter, which we'll call t. You can see that as time goes on, a parametric curve actually traces out some path in the plane, and a sort of one-dimensional twisty path in the plane is called a curve, and so that's why this is a parametric curve. It's because it's a curve that is traced out by a parameter. Sometimes we'll, instead of writing it as a point like this, we'll write x equals, and then there's some function of t, and y equals some other function of t, so maybe g. So both of these are perfectly fine ways to write down a parametric curve. This way of writing it sometimes gets called parametric equations for a curve, because they look like equations. Let's look at an example. So let's sketch the graph of this parametric curve. So x is 2t and y is minus 1 plus t. Well, you can see that if you put in any particular value for t, these two equations are going to generate a point. So we could come up with some of the points on this curve just by making a big table of different t values and the x and y values that these parametric equations produce for this particular t value, and then we can plot these points. Now this parametric curve, the domain for this is all real numbers, because you could plug in any t value at all and it would work fine. And so I'm going to pick just certain t values for this table, but keep in mind that any t value would work. I'm just sort of picking a few just to get some idea of what sort of curve this is tracing out. Really, t values in between the ones I pick sort of fill in the gaps in the curve. So let's start out with, I don't know, how about minus 2? Let's go from minus 2 up to 0. Or, I'm sorry, up to 2. Again, keep in mind that all the t values in between and the t values beyond minus 2 and plus 2 also create points on this curve. So when t is minus 2, plug that into both of these equations. So for x, 2 times minus 2 is minus 4. And then for y, minus 1 plus negative 2 is minus 3. And then when t is minus 1, 2 times minus 1 is minus 2. And minus 1 plus negative 1 is minus 2. Okay, for t equals 0, x is 2 times 0, so that's 0. And y is minus 1 plus 0, that's minus 1. For t equals 1, we get 2 and 0. And for t equals 2, we get 4 and 1. Okay, now you can see each t value has produced a point, an x value and a y value. And so what we can do is plot all of these points on our coordinate plane. So let's start at the top, I guess, with minus 4, minus 3. So that's going to be here. So there's one point on our parametric curve. And then minus 2, that's right here. And then 0, minus 1, that's right here. And then 2, 0. And then 4, 1, so right there. All right, so these points are all on our parametric curve, but remember, all of the t values in between that we didn't put in this table do produce points. You can sort of guess that all of the points produced by the in-between t values are going to fill in the gaps between the points that we did get. So you're going to get something like this. So it looks like this parametric curve actually generates a graph that is this line. Now it looks like this line is y equals maybe 1/2 x minus 1. So this parametric curve generated this line, but what's important to keep in mind is that a parametric curve doesn't just give you the shape that is traced out, but it also tells you a very specific way in which this curve is traced out. So for this parametric curve, this point here is the point where t was minus 2. This point here is the point where t is minus 1. This is the point where t is 0. This is the point where t is 1. And this is the point where t is 2. There are other parametric curves that we could write down that would trace out this same line, but would trace it out differently. Just for example, if we said that x was t and y was 1/2 t minus 1, you can see what I've done with this parametric curve is I've just imitated the equation of the line. So if we graphed this, we would get this same line, but all the points would be labeled with different t values. So a parametric curve gives you not only just a shape in the plane, but also a particular way of tracing out that shape.